We're doing a fairly complicated curve here. We have two discrete points as well as a curve that extends in this manner. This would appear to be the point -3, -3. And this would appear to be the point -2, -7. That's good to know. So we shade in on the x-axis an x value of -3 with a closed circle and an x value of -2 with a closed circle. We then consider that this would appear to be the point 1, -5 with an open circle. So we put an open circle at the point 1, -5, or excuse me, at an x value of 1 on the x-axis. We then notice that the horizontal dimension of this curve from here extends infinitely wide to the right, so we shade in our y-axis infinitely wide to the right. Okay, that's our x, that's our domain. Now let's look at our range. The y component of this point right here is -3. The x coordinate of this point right here is -7. So we've dealt with our two discrete points. We then consider that this point has a y coordinate of -5 and that it then extends up infinitely high. So we're going to extend our blue paint job on the y-axis up infinitely high. We've colored over this point. That's fine. No real effect on, with respect to the y value -3, no real effect by coloring it over twice. And so we're now in a position to state our domain. We see that x can equal -3 or -2 or be any number greater than -1. So we can write it that way. X is an element of the real such that x equals -3 or -2 or x is greater than 1. Or we can say x such that the set of all x is such that x equals -3 and -2 as well as x being greater than 1 and x being an element of the real numbers. Similarly, we look at our range. We see that our y value could be -7 or any number greater than -5 with an open circle. So we state that in our range. Our range is a set of all y's that are real numbers such that y equals -7 or y is greater than -5, or similarly the range is a set of all y's such that y equals -7, y is greater than -5, and y is an element of the real numbers.